So this correlation we have done descriptive and the basics of JAMOVI. And in that we saw that the nature of we learned about the nature of the variable, that what is a continuous variable, what is a categorical variables, what are the various scales of measurement like nominal, ordinal, interval, and ratio, and what are the characteristics of those scales. In this session, in the session of correlation, this correlation is applicable and specifically for the continuous nature of variable. So like all other session, we will also undergo this session under the following headings. First, we'll see the basic concepts. What are the basic concepts of correlation? What are the research questions to answer which we need the correlation test? What are the assumptions and hypotheses? Because in this correlation, you have to test few assumptions which we learned, like testing normality, testing linearity, that we'll see. Then we'll see what are the commands and how do we interpret it. And at the last, we will summarize each step, the commands of the each step. So this correlation is used to determine the strength of association between the two variables, and the nature of the two variables should be of continuous nature. Like we discussed the nature of the variable, continuous is like blood pressure. It is continuous in nature, where the fractional values are also possible. So both the variables should be of continuous nature, then only we can apply this correlation. And this is specifically regarding the Pearson correlation. In case of a Spearman correlation, even if it is an ordinal data, you can apply Spearman correlation. So now this correlation coefficient or the Pearson's correlation coefficient R, it has got following properties. So the value of the R, it measures the strength of association between the two variables. That means if we increase one variable, what is going to happen with the other variable. So that value of this correlation coefficient, it tells you regarding the strength of association, whether the strength is very weak or it is moderate or it is very strong. So value of correlation coefficient tells us about the strength. Now there is a sign associated with it. So this R comes as a positive or as a negative sign. So if there is a positive sign, it tells you that one variable, if we increase one variable, the other variable is going to increase. So this sign tells you the direction of relationship, whether it is in positive direction, which means that if we increase one variable, the other variable will also increase, or the negative. That means if we increase one variable, the other variable will decrease. The third characteristics or the properties of the correlation coefficient is, it, like we have already done that the value of this tells you like the strength of relationship, and it ranges from -1 to +1. So the value ranges from -1 to +1. Again, like we will study this in chi-square test also, that this correlation doesn't imply this causality. That means if two variables are correlated with each other, we cannot say that the particular factor is a causal for the other factor. And for us to study this causality, we know that there is a Hill's criteria for causal association, and you need to satisfy those criteria before we say that this factor is a causal, X factor X is causal for Y. So obviously the value of this correlation coefficient or strength of association is one of the criteria of the Hill's criteria, but this is not the only criteria. There are other criteria as well. Now, regarding the strength of association, we measure the strength of association and we categorize it into the three categories. There can be a small correlation. So when the value of R, it is up till 0.3, we call it as a small correlation. When the value of R is up till 0.5, that means 0.3 to 0.5, we call it as a moderate correlation. And when the value of R is more than 0.5, we call it as a strong correlation. So you can remember anything more than 0.5 is strong, and anything less than 0.3 is small correlation. So what could be the research question if you have to test this correlation? So like in this case, if you want to know whether there is any relationship between the serum vitamin D level and serum calcium level. So in this case, if you see, both this serum vitamin D level and this serum calcium level. These are which nature of variable? These are again the continuous variable. Continuous variable which we learned in the session 1. Then the second type of research question could be if you want to know whether there is any relationship between the duration of sleep and the percentage of marks obtained in the final examination. Again, in this case, you can see that this sleep duration, this will be measured definitely in hours. So this sleep duration here and the percentage of marks obtained in final examination, that is both these variables are of continuous in nature. The third research question could be if I want to know whether the female literacy rate of a state and infant mortality rate, whether these two are correlated or not. In this case, again, both these are continuous nature of variable, so we can apply correlation. So in all these research questions, what have you observed? So we have seen that there is both these variables are in continuous in nature and we are measuring the association between the two variables. So the appropriate statistical test to answer such research question is the correlation, or which is known as the bivariate correlation, also known as the Pearson's correlation. But we have to be very cautious if we are making categories of these continuous variable. Like in case of a transform and compute option, you learned how we can categorize the category of age, how we can categorize the systolic blood pressure, which is a continuous variable, and you can make categories of those continuous variable. In this case, all the three research questions, I have made a continuous variable. I have made a categorical variable out of a continuous one. In this case, you can see this serum vitamin D level, it has been categorized as less than 10 nanogram and more than equal to 10 nanogram. Similarly, serum calcium level again categorized as less than 5 and more than 5. Again, if you are measuring sleep duration, but you are categorizing it like less than 6 hours, more than equal to 6 hours, or percentage of marks obtained, less than 50% or more than 50%, or the female literacy low and high versus the state infant mortality rate low and high. So in that case, in all these three cases, what we are seeing that we have categorized the continuous nature of variable. For such cases, you cannot apply and you should not apply correlation. So underlying assumption for correlation is that the two variables should be on continuous scale, and the second thing is they should be paired. Now, what do we mean by paired value? Paired value means that the two values should be measured on the same set of individual or the same respondent. The respondent should be same for the two variable. We will see that in the examples also. And there needs to be a linear relationship between the two variable. And how do we check for the linear relationship? There is an option in JAMOVI, which is known as the scatter plot, and we draw scatter plot in JAMOVI to see whether there is a linear association between the two variable or not. The third assumption is that there should not be any significant outlier. And again, few outliers, that's okay, but there should not be too many outliers, and the data should be of normally distributed for Pearson correlation. Because if you are planning, if the data is not normally distributed, then you can apply Spearman. But for Pearson correlation, the data should be approximately normally distributed. So let's again revise the assumptions. So both the variables should be continuous in nature. There should not be significant number of outliers. The data should be paired. That means both the values should be of one individual. There should be linear association between the two variables. And how do we check for linear association? We check it by the scatter plot, and then we need to satisfy the assumption of normality. Now, what is this linear versus non-linear relationship? So in this case, you can see there are 4 graphs. So there's a green line in between. So the 2 graphs, which are towards the left side of this green line, that is showing the linear relationship. But in reality, you will not find a perfect linear relationship. This is like a hypothetical example. Towards the right side, you can see that it is a non-linear relationship. So this non-linear relationship again, if one variable is increasing and the other variable is also increasing, in this case also you can apply the correlation. It is not a perfect linearity, and such type of non-linear relationship is called as the monotonic relationship. Monotonic means both are in the same tone. If one is increasing, the other is also increasing. But if you see this fourth graph, this one, in this case, you cannot apply correlation. Neither Spearman nor Pearson. Because you will see that initially it is rising with the increased value. Means if you are increasing the X, the Y is increasing. But after a certain point, if you are increasing X, this Y is decreasing. So this is a non-monotonic relationship. That means both the variables are not under the same tone. That's why there should be linear relationship, even if there is a slight violation of linearity. But if the relationship is monotonic, which is shown by this third graph, then also you can apply correlation. Now there's a concept of this coefficient of determination. Now what is this coefficient of determination? So suppose you find the correlation coefficient between the two values, two continuous variable. So taking the three examples of research question which we have shown, in the first example, we were seeing the correlation between the serum calcium level and the serum vitamin D level. So suppose if the value of the correlation coefficient in the first case is 0.552, in the second case it is 0.702, and in the third case it is 0.801. In this case, you can see that this has got a negative sign, whereas the other two has got a positive sign. So these value, so if I have to tell about the strength of association, what will I say? I'll say that it is both the three variables are of strongly correlated, because what we learned that if the value is more than 0.5, then we call it as a strong correlation. So in all these three examples, this tells you that there is a strong correlation about the strength and direction. But if you square it, then it will tell you about the change in variation of one variable, how much percentage is responsible for the change in Y variable. So like if I want to know how much variance in one variable can be explained by the other variable. So like variation in the serum vitamin D level from one person to another person can be explained by what percentage of the serum calcium level, or the variation in the percentage marks obtained from one student to another student can be explained by sleep duration by what percentage, or the change in the infant mortality rate from one state to another state can be explained by literacy rate by what percentage. So if you square the correlation coefficient, like if you square 0.552, 0.702 and 0.801, the R square will be 304, 0.492 and 0.641. If you multiply this by 100 to make it as a percentage, then you can say that 30.4% of variation in serum vitamin D level is due to the variation in serum calcium level. Similarly, you can say that 49.2% of the variation in marks from one student to another student is due to the sleep duration, and 64% of the infant mortality rate variation is due to the state literacy, female literacy. So this is known as the coefficient of determination, whereas if you are seeing the variance in the dependent variable, how much change in the independent variable, how much percentage of that change in independent variable is responsible for that change in the dependent variable. So now let's see what are the null and alternate hypotheses for this. So like we say that with the sample, we try to project the population parameter. So in this case, we will say that the population coefficient correlation correlation coefficient is equal to 0. And the alternate hypothesis states that the population correlation coefficient is not equal to 0. Now let's see this in JAMOVI. So let's see the question. What are the questions which I have to show? Maybe we can, this is the JAMOVI sheet. So there was one participant who could not install JAMOVI. Could you do it? Satish, if I can recall that we talked to you in the morning also regarding your issue. Was that if I'm right? Are you there in the workshop now? Yes. So could you do it, Santosh? Okay. You tried today?
Yes, sir. So it went to reinstall. So I tried to reinstall. The network issue just.
Okay, you could reinstall it.
Yes. So it was to do it.
That's, and now is it working now?
It must install. Yes, install.
Okay.
I am using the cloud version of the JAMOVI, so that was run cloud.
Okay, okay, Santosh. So this is the question that I have to estimate the correlation coefficient between the BMI and cholesterol. And in the second question, I have to see the correlation coefficient between the BMI, and here the DBP is not there, so I'm just deleting it. This systolic blood pressure, BMI, cholesterol, cortisol, and vitamin D, and all these are the continuous variable that you can see. So I'll go to this data set. So first I have to see between the BMI and cholesterol. So what is the first step which I need to do? I need to test the assumption. So how will I check the assumption? The first assumption was that both the variables should be of continuous in nature. So both this BMI and cholesterol, if you see the data set, this is a continuous data. This is the cholesterol. You can see the values, and this BMI score, this also you can see the values. So both these are continuous in nature. Now these are the paired data because we discussed in the JAMOVI that one row is for the one patient. So you can see that this may be the name, this patient name 1. It has both these values, BMI score and cholesterol. These are of the same patient. So that means it is a paired data. So our first assumption that is fulfilled, that the two variables should be of continuous in nature and it should be a paired variable. So that is there. The second is you have to check the normality and the outlier. So how do we check for normality and outlier? Yes, please type in the chat box. How do we do that? Box plot, QQ plot, Shapiro-Wilk. Yes, Shapiro-Wilk we can do, Sumit, but Shapiro-Wilk, what is the criteria for Shapiro-Wilk, Sumit? When do we do that? Will we check with Shapiro-Wilk in this case? The total number of sample size is 180. Again, you should know the Shapiro-Wilk and what is the if I want to check it with Shapiro-Wilk, when will I say that the data is normally distributed? What should be the p-value of that statistics? Yes, all of you, please type in the chat box so that I'll come to know whether you have understood the first session or not. So what should be the value of Shapiro-Wilk? So it should be more than 0.05. Yes. So all of you are right. So now that means you have now understood the first day session. Yes, if p-value is non-significant. Neeraj, Dinesh, all of you are right in this context. So we'll see that how do we do that? We go to the explore, descriptive. Then I'll shift these two variables, BMI score and cholesterol. What should I click here? I'll uncheck this. I'll go down and check this, go this with the plot option. Excuse me. I'm sorry. And then this QQ plot and box plot. So what is your interpretation of this BMI score? This is the box plot and this is the QQ plot. This, is it a normal box plot or outlier? Yes. So outlier present. What about cholesterol? So you can see that box plot of this cholesterol, that is normal. Right. So if we see this box plot and QQ plot, so we were discussing regarding this BMI and cholesterol. So if you see this BMI, this you can see this. So this is, there is an outlier here. In this case, these are the outlier. And but if you see the QQ plot, it is approximately normally distributed because most of the data points are across this diagonal line. Similarly, if you go down and see the cholesterol, there is no outlier in the cholesterol, and there this is also approximately normally distributed. So we can both these assumptions are met. Now I'll go to the correlation. So how does this option of correlation come? You have to go to this option of regression. In regression, you can see there is an option of this correlation matrix. So click on this correlation matrix and then this will come. So now I have to shift two variables here because right now I'm checking for only two variables. So this cholesterol, BMI score and cholesterol. I'll shift in this window, and then you can already by default it is the Pearson which is clicked. But if the data is not normally distributed, you need to uncheck this Pearson and check this Spearman. But since in this case the data is normally distributed, I'm going to this Pearson. So Sumit, your question we'll answer at the last, why the whiskers are not equal on both sides. That I will take this question, answer this question maybe at the last of the session because it will take some time to answer. Okay, but remember, make me remember that I have to answer this question. And then your this correlation matrix, again plot I need to know, because this correlation matrix, this is basically the scatter plot which it shows. So this scatter plot, it will show you the scatter plot. So before you see the value of this, you need to go down and see. So in this case, you can see, although it is not exactly, it is not very linear, but there is a monotonic relationship between these two variables. So you can go for the correlation. And again, then you can go for this value of this correlation coefficient. You can click this confidence interval also if you want the upper and lower value of this Pearson's R. But this is a strong correlation since the value is more than 0.5. And if you click this flag significant correlation, then you will see that it comes as a star mark. So in case of a multiple correlation matrix, it tells you the all the values of significant correlation, it comes as a star mark. So it is easy for you to visualize. So you can click that also, this flag significant correlation. So this is how you do it is just the demo of two continuous variable. Now, if you want more than two variables to be tested together, how you can do that? In this case, since the coefficient of determination that you have to calculate, so you can square it like 0.675, and then whatever value comes, you can multiply that with 100. Maybe it comes like maybe 49% or something, we'll see. And that is the value of the coefficient of determination. So along with the value of correlation coefficient, you should also report the value of this coefficient of determination. So along with this, if I want to test like systolic blood pressure, maybe the vitamin D level, cortisol. So all these are there. Now I have to test for the normality also. So I'll go up. If you click this result, this one, this window gets active. So now this normality window gets active. So you can now shift these variables also, like SBP, cortisol, all these variables here. and you can see their QQ plot and box plot. So you can see like this is the cholesterol. This is normally distributed. This is vitamin D. So you can see that vitamin D, there are many outlier, and this is not normally distributed. Many, it is going like this, and it is not normally distributed. You can see this SBP, it is approximately normally distributed. Cortisol is again normally distributed. So in this case, if you see, I think vitamin D, that is not normally. Yes, I'm not speaking because I was just checking why. I don't know what is happening, because everybody's is connectivity is maintained except me, because there are other people who have joined and now there is no issue with them. I don't know. I'm sorry for this. And maybe in the breakout room, we'll resolve this issue till the time you people are doing. So yes, there was a question regarding the dependent and independent variable. So basically, per se in correlation, we don't define dependent and independent because we want to see the association between the two variable. But this dependent and independent concept, this is more applicable when you do the regression, whether it is a linear regression or whether it is a logistic regression. But in correlation, it is up to you. You can take any, because it's for the two variables. So the value is the same between the two variable. If you take, in this case, if you take the BMI, but generally what makes sense, because BMI, you will say that if you increase the BMI, the cholesterol increases, the value of cholesterol, because the other way around is generally not possible, that if the cholesterol is increasing, the BMI is increasing. So in this case, what makes sense that, with increasing BMI, the value of cholesterol is increasing. So if you want to say like in this case, then you can calculate between the BMI and cholesterol. But like if you are seeing the cholesterol and CRP, maybe for BMI, you can say that it should be the independent variable and cholesterol should be the dependent one. But if you want to see the correlation between the BMI, CRP and cholesterol, then which variable you will take as a dependent and which variable to take as an independent. And many times you will do like in pathology and biochemistry, a lot of people, they are doing this NC ratio, the correlation between the value of the neutrophil and the NC ratio, lymphocytic neutrophil ratio and all those stuff. There also it is not very easy to define, and it doesn't make a sense also, because whatever is your research hypothesis, you can make that as a independent and the other variable which you want to test. So it is entirely up to researcher if you want to, because if your assumption is like on the basis of this independent and dependent variable, because usually you are not restricting yourself up to the correlation, you will definitely go to the regression. So if you have this end point of regression in your mind, then in that case you can take the dependent variable, whatever you want to test, as a dependent, and all other variable as a independent variable. So that you can do. Am I making myself clear? Or do you want to, did you get your answer? Let me check the chat box. But how do we interpret coefficient of determination? Yes, the coefficient of determination is the same. In this case, it is up to you. So you want to see, and you will, in this case, you will see the biological plausibility also. Now, what is a biological plausibility? Generally, if you see that, maybe if you want to test between the CRP and cholesterol, will increase level of CRP, will it cause the increase of cholesterol? So it will say generally no, because the biological, in this case, the biological plausibility or the mechanism or the pathological mechanism which is happening inside the body, that is also important. So that you need to say that which variable is changing and can it cause the change in the other variable. So that should be there in the mind whenever you have this concept of dependent and independent variable. So in this case, like maybe BMI, you can say that this BMI, maybe with increase in BMI, 49% change in the cholesterol is due to the change in the BMI. And that's why maybe in regression, you will see that this R square, you don't have to calculate the R square. It comes as a default output option in the regression, because that case you have definitely defined the dependent and independent variable. In case of a correlation, since there is a no, you shift both these variables in one window, in this case, this variable window. So that's why in when you are performing the command, then it doesn't ask you like, in that case, it is the researcher who has to interpret. So did you get this, Neeraj? Regarding this concept of dependent and independent, because you have to transfer your variable, and this software doesn't ask you regarding the independent, but yes, depending on your research question, what you have, because research question, how do you make research question? Yes, I'm sorry, Nidhi, in between, I don't know why this internet is playing this game, going and coming again. Maybe I will try to, I'm sorry for all these, I'll again repeat. So I was just telling like this concept of dependent and independent. So this dependent and independent, in case of a correlation, it is the entirely researcher choice, because software, whether it is SPSS or JAMOVI or any other software, it doesn't tell you.
Ma'am, we can try switching off the video.
Okay, let me do that. Okay, let me do that. I'll try. Up till now, are things clear? Between two variable. Am I audible now? Okay, so did you get this, the correlation? Okay, so I hope things gets resolved soon. So with this, I will again show you the multiple correlation. So we were seeing this now, this vitamin D. If we see this vitamin D, it was not a normally distributed curve. This is definitely not normally distributed, because you can see there is a definite curve going up. So what I'll do, I'll shift this back to this box, because then I cannot do a Spearman in this case. I have to do a I cannot do the Pearsons in this case. I have to go with the Spearman. Since if you see the statistics already, so this was the for the checking of the descriptive. So now I'll go to this and I'll shift this vitamin D back to this box, and then you can see first you have to see this is the correlation matrix. So this you can directly copy and paste it while you are writing your manuscript. So you can see this is the correlation between the BMI score and cholesterol. These two are between the BMI score and SBP. This is the cholesterol and SBP. Again, this is the cortisol with all these three. So this is the correlation matrix, and you can see that there is a linearity between these variables. So we can go for the correlation. As I have shifted the vitamin D back to this variable box, because it was not normally distributed. So it is only these four variables which I can take in my result. And then you can come up and you can see there is only one correlation coefficient. This is 0.675, which is significant. Whereas the other correlation coefficient, none of them is having a star mark. So we can say that none of the other correlation is significant. And this table, you can directly copy paste it. And in this case, you should enter these variables, or you can change these variables in the Word document also. And then you can write your interpretation. You can write your interpretation here, or you can again write. So while you write your interpretation, you have to give the assumptions also. So in this case, you will write that normality was met and there was few outlier. And you can say that, the linearity, there was a linear association between the variable. And that's how you can write your interpretation, that this is the value of correlation coefficient between the BMI score and cholesterol was significant with a strong value with this much of correlation, whereas the other were not significant, as shown in the table. So that's how you can write the interpretation. So this is for the correlation, bivariate correlation. And then we can, I think this is the write-up. Let me show you how to enter the value. So this is the dummy table. You can see we have taken the variable as A versus B, and this is the Pearson correlation coefficient, and this is the coefficient determination. And you can write that the Pearson product moment correlation was done to assess the relationship between these two variables. Preliminary analysis showed that the relationship to be linear with the both variable and normally distributed as shown by the QQ plot. There were few outlier or no outlier in the distribution as seen by the visual inspection of box plot. And there was a statistically significant or not significant small, moderate, or strong correlation, positive, negative correlation, depending on the sign between A and B with the value of R. And you can write that this much variable, like 49% of the variation in cholesterol was explained by the BMI, change in the BMI. So this is how you can write the interpretation. Similarly, with the other matrix, this is the table. This is the same table which you have seen in the JAMOVI. You can copy paste that, and then you can write write up depending on the value and its sign. So you have to include the assumptions whenever you frame or write a interpretation for a correlation, bivariate correlation. So is it okay up till this point? Or should I, do you want me to repeat any concept before we go to the breakout room, or any question which you want me to answer?
Ma'am, regarding that matrix, if you can go back to the matrix.
Yes,
Yeah.
I am going back. Yes, Neeraj. This is the matrix.
I need to know how to read, like in that matrix, how to read the values in systolic blood pressure. Like, is the
This
relation?
one? Okay, you are asking about this matrix.
So here, if you see SBP and cortisol,
Yeah.
how do we interpret the results for SBP? Like, is it is SBP correlated with only with BMI or the cholesterol or other cortisol?
No, other it is not correlated, because you will see that it is this is not significant, and the values are also very less. It's 0.05, 0.04. If you see the value of R, it is very less, and that is not significant also. None
And
of the, yeah.
I just wanted to understand this particular correlation coefficient is influence, like SBP. This particular matrix is for SBP with all the others, or SBP with BMI only for this one?
No. With every, see, you have one vertical column and this one horizontal. So this one vertical, you can see BMI, cholesterol, SBP, and cortisol. Similarly, you can see the 4 variables. So this gives you the value only with that respective one. Like with BMI and BMI, it will not give, but BMI and cholesterol, this is the table. So I'll show you how to do that. So this is, if you focus on this, this is between the BMI score and cholesterol. If you see this SBP, the first one, it is with the BMI and SBP, and the second one, it is the cholesterol. So you can see from top, this is the cholesterol and this is SBP. So this is between the cholesterol and SBP. Now coming to the bottom one, this is the first one. This is between the cortisol and BMI. The second one, this one, this value, I missed this. This was included in the first one, this one. The second is between this cholesterol and cortisol. And the third column, it is between the SBP and cortisol. This one. This you wanted to ask?
Yes, ma'am. Okay, ma'am.
Okay. So there is a vertical column. This one. Sorry, just a second. There is a vertical column and there is this horizontal column. So if you have done analysis in SPSS, you may recall that SPSS populates data in all these cells. So with the same variable, like it will put 1 here with BMI and BMI. With cholesterol and cholesterol, it will give you 1 here. So it gives the output all cells populated. Whereas JAMOVI, that leaves these cells blank, because there is no point having the correlation with its own variable. So that's why we say that we can directly use JAMOVI table, because in SPSS you need to remake the table. You cannot use that table because it gives you like 1 with all the label. Okay. And then any other question? See, this is just just to show you the example of continuous variable between the cortisol and cholesterol, maybe whatever the variable, I have not taking the biological plausibility concept right now. Okay, this is just for demonstration purpose. That when one continuous variable is increasing, the other variable is also increasing. Because whenever we perform such analysis, the researcher has done a thorough review of literature. So he is well aware of the facts regarding whether that possibility exists or not, because you have to explain the findings of your result also, and that you do in the discussion. So if something unusual, if you are thinking, or if something of that sort comes, then you have to write the interpretation that why, the increase in cortisol or increase in cholesterol might cause the increase in cortisol, because cholesterol and cortisols are related. Because the molecule of cortisol is a cholesterol. I'm just saying out of that. I'm not saying, because I have not done a thorough literature for these things. Like maybe now you can say that SBP and cortisol, but again there might be case that if the cortisol level is increasing, it may give rise to increase in systolic blood pressure. So that physiology which is running behind it, you need to find it out. This example I have only taken from the point of a continuous nature of variable. I have not gone into the physiological concept of increase or decrease in these variable. Did you get that? It is just for demonstration purpose. So you may look into, whenever you have your research question in your mind, definitely you look into all these variables and you pre-plan, like you want to see correlation between what two variables, or if it has come, even if inadvertently you have not thought of it, but if it is coming, then again you go back to the literature and try to search whether there is some association exists or not, and then you write the discussion. Okay. So if it is okay up till this point, any other thing which you want me to repeat or explain?